Let's review something you are going to see in any calculus class. It's called the trapezoid rule, and I'm going to give you two examples. One when the intervals are not evenly spaced out, and then a formula for when they are. So here's an example where they gave you the table, and you're going to notice that the x values are not evenly spaced out. So if you want to estimate the area underneath the curve from -5 to 5, I'm going to draw a quick sketch. That way you can visualize the trapezoids here. And for areas of a trapezoid, we're going to use 1/2 times b1 plus b2 times the height. And just looking at the first trapezoid on the left, that's our b1. Here we have our b2, and the height is the distance from each x value. For the first trapezoid, the b1 is going to be 10, b2 is 7, and our height is 2. We continue that process for the next trapezoids. Hopefully you can see a pattern that a lot of the points in between repeat 2 times. Adding these up, we get an estimate of 159/2. But now let's talk about what happens when everything is evenly spaced out. If we want to estimate the area underneath the curve of f of x from a to b using the trapezoid rule, then we can generalize it into this. Notice that the f of a and f of b do not have a multiple of 2, but every value within the interval is multiplied by 2. So if we wanted to estimate the area underneath the curve from 0 to 5 with 5 intervals, these are the values that we're going to test. I set up the value on the outside. F of 0 only shows up once. And I multiply all the other values by 2 until I get to f of 5. And there's my estimate using the trapezoid rule.